Today we're going to talk about speaker impedances, what happens to your amplifier depending on the speakers that you hook up to it. And I'm going to give a simple analogy of using this here as a water pipe, and down under here is a water pump, and you turn that pump on, and with nothing impeding the flow through that big pipe, that pump down there is going to be working itself as hard as it can to push all that water through that pipe. If you put some back pressure on the pipe by closing off some of the flow, that pump down there doesn't have to work so hard because it's not pumping all that water through there. It's pumping a lot less. So the odds of that water pump down there lasting a long time increases dramatically compared to having no resistance and the thing just running wild. Well, your electrical wires coming out of your receiver or your amplifier operate the same way. There's juice flowing through the wire to the speaker, and the speaker has a resistance. We can call this like 4 ohms, 8 ohms, 16 ohms of resistance. If you run your amplifier with an 8 ohm load on it, the outputs and the heat in your amplifier will build up a lot less than if you run it at 4 ohms or even get down to 2, where that juice is just running like crazy. Now most of your speakers are anywhere from 4 to 8 ohms. And if you look at the back of your receiver or your amplifier, you'll see something written like this. If you have, like on your receiver, you got some buttons that say speaker A, speaker B, and then you got a left and right for each speaker. If you're running speaker A or speaker B, your speakers can be between 4 and 16 ohms of resistance. If you're doing speaker A and speaker B, the impedance has got to be between 8 and 16 ohms. And the reason for that is because internally on your receiver or your amplifier, when you have speaker A and speaker B, when you hit speaker A and speaker B and turn them all on at the same time, those wires inside your amplifier are simply parallel connected together. Plus to plus, minus to minus. So all 4 of them are running in a parallel situation. And I'll show you what that means to your amplifier. Here we got a speaker. That's 8 ohms. So if you run 2 8 ohm speakers parallel connecting, plus to plus, minus to minus, this is the load that you're going to be putting on your amplifier. .4 ohms. So you're lowering the impedance rate low enough that your amplifier is now working harder than it was working if you're just running one speaker at 8 ohms. So when they tell you speaker A plus speaker B, you have to be 8 to 16 ohms. They tell you that because when they're parallel connected, just like we showed you, the load on your amplifier becomes 4 ohms. If you're just running one speaker and it's a 4 ohm speaker, then 4 to 16, your amplifier will work. But remember, the lower the impedance, the greater the flow of that energy coming through that wire, and the hotter and the harder that amplifier has to work. Now, if we take these speakers, the other type of connection is called a series connection, where you don't do plus to plus and minus to minus. The juice comes into the plus, comes out of the minus, and goes over to the plus of the other speaker. And now this is a series connection. Now we are at 8 ohms. Now look what this connection will do to your amplifier. See that? You're at 16 ohms. At 16 ohms, you're running your amplifier super, super, super cool. So when you series connect, you're cutting down the power output of your amplifier a little bit, which means you have to go a little further on the volume knob, but you're allowing your amplifier section to run really cool and less distortion, and the longevity of the parts in there it's gonna last a lot longer because you're not pounding the hell out of it. Now let me hook these things up to 4 ohms and show you what that'll do. Okay, this is about 5 ohms. About 5 ohms. So if these are your speakers and you do speaker A and speaker B, and these things are internally, again, parallel connected into your receiver, that's what you're going to end up with. You're going to end up with less than 4 ohm load on your amplifier. This is 3.2. It could drop down into the 2s. And anytime you run below 4 ohms, immediately you're dropping below what the manufacturer says is the lower limitation. So you're below that already. And the lower the impedance, again, the higher the heat coming out of your amplifier and the harder that amplifier has to work. So you're always best to keep that resistance 8 ohms, and if you have a choice of going down to 4 or up to 16, go up to 16. Now let me show you another type of connection. And this type of connection I'm going to show you is going to be series parallel. So we're taking these 8 ohm speakers and we're paralleling those wires together, plus to plus, minus to minus. We're doing the same thing with another pair of speakers. Parallel, plus to plus, minus to minus. Now that load on your amplifier has dropped, just like we showed you before. So if we take 4 speakers, parallel, these are going to be 4 ohms too. Now if we take all of these leads and we series connect these together, so the plus comes in, juice comes out of the minus, and it loops over to the plus of the other speaker. You're taking a 4 ohm load and a 4 ohm load, and you're series connecting it up to 8 ohms. So if you took 4 speakers, hooked them up series parallel, just like I showed you just now, you can keep an 8 ohm load on your amplifier, drive 4 speakers, and your amplifier won't work itself to death at all. If you take these 4 speakers and parallel everything together, you're going to end up at 2 ohms. And I could almost guarantee you that any of the vintage equipment, and a lot of the modern equipment too, if you start running those things at 2 ohms, you can kiss that amplifier goodbye after a short period of time, because it's going to be running red hot all the time. And you won't have to go very far in the volume knob, because you're reducing the resistance in your line so much that the juice is going to flow like crazy through there, just like the water flowing through that pipe. So you got to be really careful when your speakers up that you maintain an impedance that's higher than what the manufacturer warns you about. And like I say, if you can keep 8 ohms or higher resistance on your amplifier, that's going to give you the lowest amount of distortion. It's going to let your amplifier run cool. It's just way better. That amp's going to last years longer than if you're running that thing at 2 ohms. I'm going to show you something here now. Back when we were doing our stereo installations back in Wisconsin in the 70s, a lot of times we'd do a restaurant or a bar or somewhere where you don't have to have big bookshelf speakers and a big amplifier and drive the things real loud to have everybody in the place hear it. Most of the time when that happens, if your speakers are up in here, they're real loud, and over in this end of the room, the people have trouble hearing it. So we would do ceiling installations with 8-inch coaxial speakers, good speakers, not the little cheesy junkers that you get for $8 a piece. And then we mount them in the ceiling tiles, spaced out in that room. And what you do in a case like this, you're doing series parallel connections, just like we showed you here. So you're going to maintain an 8 ohm load on whatever amplifier you're using. And then when you put the speakers in there, you're not hooking them up all right channel, all left channel, because if you do that, people on this side of the room are just going to hear the right channel. They're not going to hear the stereo. Same thing over here. All they're going to do is hear the left. So you stagger them. Right, left, 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 right. And now you can see where those people are in the room. If they're here, they got stereo. If they're over here, they got stereo. If they're over here, they got stereo. No matter where these people are in this room, they're all going to hear a stereo sound. And if you use a good 8-inch coaxial speaker with a tweeter and you use conventional ceiling tiles, we'd get those speakers in there and just lay a piece of fiberglass insulation over the top of the speaker, and you would be surprised at, when you listen to this system, how good it would sound compared to the little junker $5 speakers that you can put into a room like that. So this was a way to maintain a really good impedance on a receiver or an integrated amplifier and get the sound throughout that restaurant or bar or whatever area you were filling up. We did pizza houses like this. You're distributing that sound all over the place, the same volume, so wherever you are in here, you don't have to be on this end of the room and get blasted out and be over here and hardly hear it. Everywhere you go in here, that sound is going to be even. It's going to be stereo. That was the way we did it almost, well, all of the time in a lot of these installations. And you were able to maintain this thing operating without failure by doing your proper series parallel connections, using 8 ohm coaxial speakers, and running with an amplifier that's got a decent amount of power, but you don't have to have an amplifier that's got tons of power. You're operating small speakers and you're operating them at 8 ohms. so you'll accomplish that goal. We did it all the time, and we never had to worry about anything blowing up or overheating or anything like that. It's a very, very simplistic installation, and the key to the whole thing is, just like we talked prior, is to maintain that 8 ohms or higher resistance on your receiver or your amplifier. You want that amplifier to run cool. You don't want it to be working itself to death. And in a situation like this, it won't be. Now in people's houses, this is kind of a simplistic drawing, but in a room, say you got a couch over here, a couple chairs, you got your stereo stand with your stuff on there, and you got right and left speaker. And you want some rear speakers because you want 4 speakers in a room, speaker A, speaker B. To start with, you got to be positive. If you're going to take your receiver here and do speaker A and speaker B simultaneously, you got to make sure that all of these speakers are 8 ohms or higher, so that when you push in speaker A and speaker B, you're running your amplifier on here at 4 ohms or a little higher. If the speakers you start with are below 8 ohms, if they're 6 ohms or if they're 4 ohms, then you got to hook everything up to speaker A and do a series connection just like I showed you before, and take your speakers in this room and you do the same thing. You stagger them. You take the left over here and you push the left to the other side in back. Same thing here. And what you gain out of that is the same thing. Wherever you are in the room, you're going to hear stereo. It fills up the room, balances the sound out real well. You're maintaining your proper impedance load on the amplifier, and it'll sound really, really good. It'll sound amazing. You won't believe how good it'll sound and how long that amplifier will last and how distortion free it'll play, as long as you maintain these proper impedances on that amplifier. Okay, now I'll show you something else. Now when we did an installation like this, the speakers would all go above the ceiling tiles and they'd run wherever we had the amplifier that we were using. And you know, in a situation like that, you end up with some long speaker wires. We would take lamp cord, or you know, something that didn't cost a ton because you don't need it, and we'd just do plus and minus connections on each of these speakers, and we'd just run those wires and have a whole bundle of them down where our receiver is going to be. We didn't mark anything. We didn't mark this speaker right and left, plus and minus, and do all that, so we had a clump of wires down here with all kinds of labels on them or stickers on them or anything like that. We just ran them all and let them lay in a bundle like this. We'd have 8 of them just hanging there, and then we had to hook them up. So in order to determine what wire goes to which speaker, real easy trick without having to run up and look at the wires or mark the wires all over the place. You simply take a battery, simplistic battery, and have somebody in the room to tell you, yep, that's this speaker here, that's that one. So you know what that one is. You do the same thing with all the speakers, and you identify the speakers with your battery. Real simple. And to determine plus and minus, you know, we would always use something so that we'd have like a red as a plus, a black as a minus, or we had a lamp cord where one side had a mark on it so you knew what plus and minus was. But if you didn't have something that told you what plus and minus was, and you thought, oh, now what am I going to do? I got to do a series parallel connection. I got to know what plus is and what minus is. I can't just guess. I've got to know. So in that case, here's a real easy way to determine what the plus wire is and what the minus wire is. On your battery, you always got a plus side and a minus side. So just take your speaker wire, doesn't matter what side you put to what, touch it and look which way that woofer is moving. You see how that woofer is moving in? You want that woofer to identify the plus. You want that woofer to move out when you touch the battery. See how the woofer is moving out now? That tells you there's the plus on your battery. That wire that you're touching that plus to, that's your plus wire. So you can identify plus and minus with a battery. You can identify where all those speakers are with a battery. Real simple. So doing installations like this, they can still be done today without any problem at all and sound amazing. And there's a proper way to do it and the wrong way to do it. A lot of guys will just take and start running these wires and plus to plus plus all the way along. And if they do that, it'll be like we saw before, where you're down to a 2 ohm load or less on your amplifier. And even though they're small speakers and you're not turning the volume up that high, it isn't going to matter, because very, very low resistance, that amplifier is going to be working itself to death to push that energy through that wire. So once again, impedance and the load on your amplifier is a critical thing. If you have a choice and you can get the impedance higher rather than lower, take the higher road. Don't do 4 ohms if you can do 16. I know some people will say that's crazy. You know, the amplifiers will run fine and all that stuff. Well, maybe they'll run. But like I explained, the higher the resistance, the easier that amplifier runs. So just keep this stuff in mind when you're hooking up 4 speakers or multitudes of speakers to one amplifier.